Hello everyone, I'm very excited to be here for today's webinar, from days to hours, OCAST maps software dependencies with graph technology. My name is Villedieu, I'm one of the co-founders of Linkurious, and for today's webinar, I'm joined by Olivier. Olivier, do you want to say a quick word about yourself?
Yes, sorry, my mic was mute. Yes, very happy to be here. Olivier Bonsignour, so I'm the head of product development at CAST, and I'm going to explain what it is exactly later, I guess.
So let's get started. First, maybe a quick word about Linkurious. The company was founded in 2013. Right now, we are a team of 50+ employees, and on a daily basis, we are serving thousands of analysts throughout the world who are using all products to make sense of graph data. You can see here some of our partners and clients. We are working with the likes of Neo4j, Deloitte, but also Zurich Insurance, HMRC, Pioneer, and much more. So I want to talk a little bit about today's agenda. First, we will start with a bit of an introduction to Ogma, Linkurious JavaScript graph visualization library. Afterwards, we'll talk about adding graph capabilities to your own applications. And then we'll dive into a very specific case study around OCAST transform data into knowledge to meet high performance expectations. Afterwards, we'll do a demo, and finally, and hopefully, we'll have some room for Q&A at the end of the session. So let's get started now. So this session is going to revolve around Ogma, the all-in-one JavaScript visualization library for large graphs. Ogma helps teams of developers and product people create rich and scalable graph visualization apps. It does so for three main reasons. First, with Ogma, you have the ability to display very large graphs in no time. And then there's the ability with a large ecosystem of built-in components to deliver very rich and interactive user experience. And finally, all product experts are with you along the journey to help you succeed in your implementation of Ogma. The end result is that Ogma helps you save time and a lot of hassle developing powerful graph visualization apps. So that's it for a quick intro to Ogma. We have clients that are using Ogma in a wide range of scenarios, pretty much wherever there's some graph data. So we have clients using Ogma for economic crimes, others in the domain of intelligence and law enforcement, others still for cybersecurity, data governance, life sciences, supply chain, and so much more. So how does Ogma work? Here you have a bit of an architecture overview. It all starts with the data that's stored in your database. And the first step is retrieving that data. So you need to connect to your database and execute a query and receive the response. Then that response needs to be translated into Ogma's format. So that means passing the data and converting it to the Ogma format. And we have some plugins to convert, for example, Neo4j style data or other popular formats. And finally, the data can be rendered on the screen via Ogma. So very simply, the graph can be rendered in your app with native integration with popular frameworks such as Angular, Webpack, React, Vue.js, and more. So that's it for a quick introduction in terms of how Ogma works. And with that, I want to pass the baton to Olivier.
Yep, thank you. Thank you for the introduction. So as I said, I'm working for a company which is called CAST, and I'm briefly going to present what we do and why we do what we do, basically, and then present the product where we are using, leveraging Ogma and Neo4j. First of all, I mean, the company was born out of a statement, which was that software was complex. Even when we started back in 1990, I mean, that was already the case. I mean, I'm not old enough to know to be part of that start, I would say, but I know I've discussed with our CEO, and that was one of his main focus was to try to find a solution to software complexity and help people to do what they have to do when, I mean, software engineers when they are developing and maintaining and changing applications. So that's part of our DNA, I would say, and what we are trying to do is to help people to solve these issues. In terms of company, I mean, we are, so as I said, we were founded in 1990 in Paris, in a basement, not really in a garage, but kind of similar. And today we are around 380 or 400 people across the 3 different continents. Mainly the US, where we have the headquarters in the US is in New York. Then we have obviously France, where we have our headquarters for Europe, and UK and Germany and countries, and India, obviously, and a little bit in China. To give you some numbers, I mean, the R&D is roughly 140 people working in 2 different locations, Bangalore in India and Paris, half-half. We have, I mean, some of the teams are fully in India, some of the teams are fully in France, depend on the activity and the skills and also the expertise of the people. We have customers, obviously, in the different areas and different continents. I mean, we're working mostly with the large companies, but we are also working with smaller and mid-size in different sectors like banking, insurance, retail, telco. And we've been also in the last, I would say, 24, 36 months, focusing a lot on the cloud provider, because there is a big change with the application modernization to move to the cloud. So we've been working with AWS and Azure, and now more and more with Google Cloud to help them convince their customer to move their application to the cloud and how to move them to the cloud, because what we do really help people to understand the applications and to understand how to what needs to be changed to move to the cloud. And one of the big sector or big part of our activities with the software, the system integrator, sorry, and since quite some time, more than 10 years, we've been, I mean, with the large Indian SIs, for example, or the Accenture, IBM, etc., etc. So that's it for the company. The products we have 2 main products. One which is called Cast Highlight, sorry, and the other one which is Cast Imaging, which I'm going to dig more into. Very briefly, I mean, both products aiming at the same with the same objective, helping people to deal with the complexity and the difficulty to maintain and change applications. Highlight is more like a rapid portfolio assessment thing, where we can go across several hundreds of applications very quickly and give a sense of what's inside and how the application have been built. And Imaging is going deeper and in more detail, so also going slower, I would say, in ingesting the application at a slower pace, but we providing much more details about the inner working of the application. 2 different use cases, 2 different targets in terms of people using the 2 different products. So digging into Cast Imaging now, because that's where we are using Ogma in Neo4j. I mean, same statement. I mean, I don't need to repeat, but more focus with Imaging. We are really focusing on providing what we could call technical documentation, but a live technical documentation, and more features or capabilities to navigate the information so that you can solve or do changes faster in the application. So all the idea of Imaging is really to answer questions, be able to allow people to ask their question, to have their question in mind and say, okay, I'm going to use the Imaging so that I can find the answer to my question. Question could be like, who is accessing this table, or how do I go from this page in my web app part, for example, to the data, which could be on a mainframe or which could be on a RDBMS or whatever type of data storage they are using. So that's the kind of, I would say, question that we are answering with Imaging through the graphical representation that we provide. I mean, most of the time, that's what, I mean, people I mean, it's difficult for people to get this information because it's usually residing in the head of a few people, a few experts who have the knowledge about the structure of the application, why it has been done that like this, etc., etc. So you have to ask questions, you have to find the time to ask the question, to get the answers. It's not always immediate, so you're losing time because you don't get the answer to your question, so you're doing differently, etc., etc. So again, the idea is to make it faster to get the answer, and also allows people who have valuable, I would say, who have valuable skills for the enterprise to focus more on leveraging these skills instead of constantly asking and constantly answering to the same questions because they can be answered automatically by something like imaging, basically. So, I mean, what we like to call it, it's a living knowledge base of the application internal with different graphical representation and different use case of imaging. But I'm going to show that a little bit later in the demo, so I don't need to spend too much time there. Some example of our customers. So Accenture, as I mentioned, is using CAST imaging for, I mean, onboarding their new project and discovering the project that they will have to maintain or to simply develop. And that's helped them to shorten the learning curve of the teams and also make a better assessment at the beginning when they are accepting, I would say, the new project. Infosys, it's basically the same use case, maybe a little bit more focus on the development part of the applications where they are constantly using imaging for keeping the knowledge, I would say, about the different application in their teams because they have a high turnover, I would say. So by using imaging to store the information and to gather the knowledge of the people in the system, it helps them to transfer that information to the newcomers and to the people who are coming to the team. And the MMC is more focusing on moving the system to the cloud and using imaging to map out everything and understand where they have some changes and some modifications to do to the application structure and the kind of thing. So that's 3 different use cases. It's not the only ones, but that's to illustrate what people are doing with our software. So the capabilities, I mean, again, very briefly, we have, it's not only the ability to represent the application inner structure into a graphical view, what we call map of the application, but also to navigate this information. And I'm going to show how we are leveraging Ogma, for example, to help people to navigate in information because the volume of data that we have can be overwhelming for people to understand when you don't really master the different technologies of the different layers of the application. That could be overwhelming, and we have functionalities or capabilities in the product to summarize or to work at a higher level in the information before digging into all the details of the application. So that's basically the idea, and we help also people to collaborate on a different view and this kind of approach because collaboration, if someone is, for example, entering a comment or annotating a view, that will be helpful for the next one when he will come to that view to understand what's the meaning and why someone has developed the way it has developed the application, basically. That's the whole idea there. So in terms of architecture, the product, I mean, we have 2 different pieces or 2 different parts, I would say. The first is about producing the information, producing the database of information we are displaying with Ogma, and the second part is to leverage that and display that into a meaningful way, for our end users. So the bottom part of the schema here is for the producing part. So we are basically taking everything that the application is made of. I mean, the source code, obviously, but also the database scripts, the configuration files, the project files, everything that describe the application, including some, when they are available, some data about the volume of the tables, for example. So everything we can leverage to help people to understand how it works in the application and what are the most important part and how the flow of data is going through the application. And that's what we try to capture at the very beginning. Can be connected to the different, I would say, Git, GitHub, GitLab, etc. It depends on how the source code is stored, basically. So that's, and just we are kind of analyzing everything in finer detail. So we have analyzer dedicated for each of the technologies that we are supporting. It comes from, I mean, it goes from C++, Java, .NET, and all the main, I mean, COBOL and things on the mainframe like GCL and other languages or technologies. But we also understand the frameworks that people are using in their application, because it's a very important piece most of the time to understand how a certain layer is communicating with another layer. And we have all this knowledge into what we call the analysis services dedicated for each technology, so that we can really capture and depict each of the detailed interdependencies between the different layers and the different elements. In terms of level of details, we go down to the functions, or at least that's what we display. It's the functions, the method, the column level, the column table, for example. This kind of level of details we can grab from the application source code. And these raw pieces of information are stored into a RDBMS database and PostgreSQL database, because that's the most efficient way to store all the details that we have. And we transform that into a graph, because basically at the end of the day, what we do is to have object A calling object B. So we transform that into a graph that we inject into Neo4j for the displaying capabilities or the consuming capabilities of the platform, basically. And so we have a transformation there. We inject everything into Neo4j, and then we use a front end, which is obviously leveraging Ogma to display the graphical views for our end user and to help them to navigate into the graphical view. So the other technologies that we're using for this front end is JavaScript and React. We have, I mean, the communication between the front end and Neo4j is done in Go, because we needed something which was going fast, and that was the choice at that time that we made. And I think that's it for the architecture. I mean, if there are questions after the presentation, I can answer, obviously. And I guess we can switch now to the demo. So let me know if you can see it. I guess
yes,
so.
we can see it.
Okay, so I'm not going to do a complete demo, and I'm not trying to do a demo of the product. I will try to illustrate what we've done with Ogma in our product. What are the features where we are leveraging Ogma, knowing that we are basically leveraging Ogma for the basic function, which is to map out or to present the graphical map of the application. And let me start it immediately so that you will have a better idea. But so that's a kind of view we are presenting about the applications, where we are leveraging the basic capabilities of Ogma to present the different nodes of the graph and the different relationships. So in our graph, the nodes are the objects. So a function is a node, a method is a node, a table is a node, a column is a node. So that's the type of node we have. And a relation between two nodes are usually either a call. For example, a method is inserting into a column. So we have an insert type of relationship between the two nodes. Or we have also relationships which are more composition, like inheritance, for example. That's going to be a type of relationship. So we have classified all the different type of dependencies that you can have between the different element of the application into type of relationships. And so we can, that's to allow us to ask very precise query. I mean, what is doing an insert in my column? That's something you can easily answer with a graph query, basically, instead of having to do some kind of constraints. And it's much faster to do it for specific type of relationships between the different nodes and trying to add properties and play with the properties of the relationship. There is always a compromise somewhere, but that's our philosophy or our angle of work with the graph and Neo4j. But here, what you see, so are the nodes we are using Ogma. I was connected too early. That's timeout. So the node here, and we are using Ogma to, I would say, display an icon, which is basically the icon of the technology or something that will pop up in the mind of the people who are looking at that and say, okay, that's my pages, basically, because that's the sign they know, or .NET, that's the logo of .NET and this kind of things. We're trying to be as expressive as possible, I would say, in the map, so that they don't have to learn how to use the map, and they know they can recognize their application, they can recognize the structure immediately. And the fact that we can use icons, but also image or whatever we want, or I mean, different things inside the node is very important for us to be able to achieve that goal. We are also using colors to separate the type of node. It's not the case in this one because we have less nodes, but we have a family of colors, basically by family of technologies. We have attributed a color to the family, and we are playing with gradients in the node, in the property of the node, so that we can slightly differentiate the different types, but they still pertain to the same family because they have the same root color, I would say. So that's what we do in terms of, we have rules in Ogma that we are applying to the different nodes automatically, so that when you display a C# class with a C# method, they are going to share the color. But if it's a Java class side to side with a C# class, for example, they are going to be of a totally different color, and it's going to be very easy for people to differentiate the two technologies and identify the structure of the application. So that's and we have I mean, we have the badges that we are using for the number of elements, because here what I'm showing is not the nodes, the row, or not the low level of node. It's group that we are doing, and we are grouping per type of technology. So C# class are grouped together, and we have in this application we have 159. I'm not sure it's something you can read, but 159 C# class in this application, for example, and 15 APIs in .NET that are used, and some user control, a couple of user control, web user control here, etc., etc. And in between, we have the relationship. So at this level, because we are at a group level, we are showing just one relationship. So we are collapsing sort of all the different relationships in between. But we can get the details here and knowing exactly what user control in the case of in that case, and which class is called by the user control. If you have more than 10, we have mechanisms where we are cutting because it's too much for the screen, and you can click on the top and you will get the details. That's basically the idea. That's one thing so that's a basic use, I would say, of I'm pretty sure that everyone who is using Ogma is doing more or less the same things. We have different type of badge depending on what we are displaying, obviously. One thing that we found very useful also at the beginning, and which is pretty useful to explain the product, unfortunately, it doesn't go very well through a presentation for a share screen, but is that we have animated also the display. So for example, here we are at what we call the level 5, which is the lowest level of group details, but we can show also the application structure at a higher level, which is we have 5 levels, and we are grouping into higher level groups, basically to better explain or more easily explain the application. And here we are really only using Ogma. There is no interaction with the server. It's purely done on the web browser. And it's the grouping mechanism that are available in Ogma, and we are grouping by type and some other characteristic, I would say. And you can go up to the higher level, I would say, of grouping, which is what we usually use to just present the architecture, the basic architecture of the application, where you see, I mean, how many layers and how the application has been I would say, structured. So that's also one thing nice, which is not super useful, I would say, once you know imaging and once you know your application. But when you start with the application, for the newcomer, it's pretty interesting to have this notion of animation, because it illustrates how the application is broken down into different pieces, and it helps us to convey the way imaging works by drilling down progressively into the details, basically, because you can do the reverse. I mean, either through here, or you can by simply double clicking on one node, you're going to explode, I would say, or drill or open the node and get to level 2 with, and again, that's a feature of Ogma where we can focus on some of the node and make the size different and the blur a little bit the other, so you are not disturbed by the rest of the information, which when you try to explain something, it's pretty important to be able to focus the attention of someone into a particular piece of the map or of the view, basically, in that case. And we found this pretty useful when we started to develop imaging back 5 years ago. So, and you can reset everything and go to the lowest level. What we also have are using, which is interesting for imaging, because here it's a little bit, I would say, you don't see the structure of the application anymore because you see too many different types of nodes. So if it's a little bit small for someone who's interested into the technology, but there is a way, and we have leveraged what is called the visual grouping in Ogma to represent the structure while still seeing the details, basically. So we have the notion of visual grouping, which is basically the same thing that I used before when I was showing the going up to level 1. But here I still have the level 1 group, but inside I have the details of the level 5 nodes. And that helps people to understand the structure while seeing which technology is used in which layer of the application. And if you click on the links on the node, and you can see the 2 dependencies between the different layer and go down to the lowest level, etc., etc. So depending on which, for example, the C# class is going to the server, so I have the complete path from one point to the other, basically. And again, that's a feature of Ogma that we've used in the product, and pretty nice and pretty, something that we really appreciate. There are obviously improvements that could be made in terms of positioning and everything. It's not, but I don't know how much you know about the, building something like this, a graph into a view, a 2D plan. It's not always very easy to not have too many cross between the relationship and this kind of thing. So that's pretty well done here by Ogma. So that was part of what I wanted to illustrate. If I remove the visual grouping for now, and I change my application because I just want to illustrate something else on another application. So that's automated. I can go back to this one. So this one is obviously much more complex. It's a bigger application. It's roughly 1 million lines of code. So it's not the biggest application. We have customers who have something like 50, 60 million lines of code, and they are analyzing the application, and it's a little bit more complex than that. So that's why we need the mechanisms that I illustrated and some other mechanisms to display the information without overwhelming them with tons of details, I would say. So one thing that also is that we are using from Ogma is yes. So we have the what we call the orange display, but which are basically the different layout provided by Ogma. We had in mind, and I remember we asked a question to Sébastien Heyman, the Linkurious CEO, like 5 years ago. We were because we've been working with this kind of representation and not graph. We didn't have graph technologies before when we chose Ogma and Neo4j in 2017. But we were trying to do the same thing, I would say, with RDBMS and custom-made libraries and this kind of approach, I would say, because we are a software vendor at the end of the day. So, the natural, I would say, habit is to develop everything by yourself and not look outside if there is something already doing what you are trying to achieve. And so we've been trying to do that since quite some time, in fact. And one of our main concerns when we were playing with the graph representation and this kind of thing was the automated layout of the graph to, as I said before, uncross the different links and the different relationships and not superpose or overlap the different nodes on the graph. So we asked the question, can we develop our own algorithm? And the answer was, for sure, you can develop them and plug them and call them from Ogma. So that's also one thing which is nice. You can extend basically Ogma, but what we quickly realize is that it's something that for which you need capabilities and skills that we don't have the time to acquire, basically. And that's one of the reasons why we went with Ogma, because we thought it was already pretty mature. Even 5 years ago, it was already pretty mature in terms of what could be achieved. And we said, okay, if one day we need to develop something, we will make the investment. But for now, what we see already available in terms of layouting is fairly good. So what we are doing here is just to leverage what Ogma is providing, basically the different type of algorithm, and the force and the sequential and the hierarchical, depending on the type of orientation you want. What we also leverage is the fact that we have the sync node, so being able to display the graphical user interface at the top and the database at the bottom, for example, of the view, which help also people to understand how the application is structured, because things are always displayed at the same location in the view, and that facilitate the I would say the communication of the details to our users. So that's one thing we do. I mean, we have the different options here, but that's more details, I would say. So the last thing I wanted to show very quickly is what it's again, we are leveraging Ogma for that, but same capabilities than before. But when we have the ability to drill down into what we call drilling down into a node, which is basically showing the details inside the node, and we are using the community algorithm. So we have developed our own, I would say, community algorithm, but we are using Ogma to group, using the logic that we have in our algorithm, to group the object under a certain, I would say, group, so that you're not, as, I don't know, I wasn't maybe a little bit too fast, but we have like more than 2,000 classes in this group of in this application. And what we do is to group them by packages. I don't know how much you know about Java, but there are basically packages are grouped which are made by the developer, decided by the developer, and we are grouping the Java class according to this structure, so that the developers, when they are looking at the application and looking at imaging, then they have the same structure. So it's easy for them to follow the flow, and they see at this level all the different dependencies for a given package. And they have the different packages that are in the view. So we have the COM, obviously, which is the most important one, because that's root of most of the package name. But there are a few here. Evan, that's the second one. And the third one, which is org at the top. And from there, people can, again, drill down and either expand everything, but this one is a little bit big, and it's going to overwhelm a little bit the display, but or you can drill down. And again, we are leveraging Ogma to go one level deeper and display the information level by level, so that, again, we are not overwhelming the people, the users, with the information. And that's purely Ogma here. There is nothing going to the server. It's totally, we have all the data in the border, and we are using Ogma to regroup what we grouped before. So degroup and regroup, basically, on the fly, the different classes that are grouped under this node. So it's pretty fast most of the time. I mean, when there are a very huge volume, like 20,000, 25,000 elements that are grouped inside, it's a little bit slower. That's what, but also our algorithm might not be the most efficient one, and it's also written in JavaScript, which might not be the most efficient language for that. But it's pretty fast, and it's very, very easy to use. So that's one good, I would say, also good thing that we could leverage from Ogma when we develop the imaging system. So I don't know if I expand everything. Takes a little bit more time, but you see it's there, and I have more than 1,000 nodes here, and it remains totally usable. Obviously, there are many relationships in the graph, so that's one of the issues. That's one of the reasons why we are displaying progressively, to allow people to focus on part of the application instead of displaying everything like this, which is something nice, but not always usable when you try to I would say understand the application and dig into the details. But you can see it's pretty fast, and again, it's done on a large graph here. I think that no, there was one last thing I wanted to illustrate from Ogma again that we use to again help people to better understand their application is what we call the not the annotation but the capabilities to insert either text or shape in the view, so that you can highlight part of the graph. If I not always super easy to grab, and you can say, okay, this part, for example, is going to be whatever, and you can attach a text to this, and it's going to be completely attached to the graph and easy to, we can even save the view, and when we save the view, we save the structure that on the shape, for example, and so when we redisplay the view, it's going to be redisplayed. And again, it's a way for us to capture more information. If you insert a text, for example, someone can insert an explanation about something, so that the next people or the next person looking at the view will have the explanation coming from that person. So it's always, when you develop application, you usually make some choice which are not always obvious after 6, 9, 12 months. And it's important to be able to explain them. And so you store the information, you keep the information so that you can transfer it to the next people maintaining the application. We have other mechanisms where you can also really annotate the view. And there we have a similar to Post-it. Again, it's a capabilities of Ogma that we are leveraging to be able to display something like this. And I remember we were working with one of Ogma consultants to build that because it was a little bit tricky, but works pretty well now. You can slide a Post-it, and some of our users are very pleased with this notion of Post-it, and they like the analogy with the regular Post-it, basically. I think that's it I wanted to demonstrate today. I was maybe a bit fast, I don't know, but so that's all the different capabilities that that's not all the different capabilities, sorry, that we have developed, but that's the main one using Ogma, basically. That's it for me.
All right, great. Thanks, Olivier. I'm just going to go back to the slides here. So thanks for that presentation and for that rich demo. It was really nice to see. Just as a reminder, if you haven't done so already, you can go ahead and submit your questions in the Q&A section of your screen. So let's go ahead and get started with this first one. Olivier, how long did it take you to implement Ogma?
Well, it was pretty fast because we played a little bit before buying it first, before entering into, I would say, the contract. We have an OEM contract. I didn't mention that, but we have an OEM contract with Linkurious for Ogma, and we did some tests. And I would say the functions and the library is pretty self-explainable. Basically, the names and the way it works is similar to the way a graph works. You have nodes, you have relationships, edges in that case, but not the same thing. And when you know the graph terminology, it's exactly the same. So it's very easy to, I would say, navigate inside the different functions. Now it's a bit more complex. I would say that if we hadn't started like 5 years ago when the library was smaller, maybe we would have more difficulties now because there are more functions, more capabilities in the library. But for us, that was pretty easy. No, so I think the first version, as far as I remember, the first version of our product took like 5 to 6 months. And a big part of that was to understand Cypher and Neo4j much more than Ogma. Ogma was pretty straightforward.
All right, thanks. All right, during your demo, actually, you kind of mentioned why you didn't end up developing your own graph library. And there's a question here that says, why did you choose this library then over other commercial libraries?
Well, the first reason is because the way we came to know Linkurious was through Jeffy. I don't know if, that's a project that was developed back, I think, in the end of 2000, something, 2010. And Sebastian, so the CEO of Linkurious, was one of the researchers working on Jeffy. And we made some prototype in 2011, 2012, 2013. We worked several times with Jeffy trying to leverage it to do what we wanted to achieve. for real, I would say, not just prototyping. We searched for Sebastian because we said, okay, we need some help there, and we learned that he had founded Linkurious, and so we started to look at Ogma. That's one of the reasons. And the second reason is at that time there were not so many robust and stable library for graph, I would say, on the market. We are a software vendor, so it's always a bit of a trade-off for us between open source, specifically back in that days. I mean, open source was not as stable as it is now, so it was also something to consider. We also needed some kind of support, obviously, because if we were making the decision to not develop, it's not for us to start investing our time in maintaining and making some changes. So we needed to make sure that the company was stable and solid, and that the people that were working in the company knew what they were doing. And Sebastian was a big caution for that, I would say. And the third reason was that we are French and they're French. And so, as simple as that. Sometimes it's easier to discuss in your own language, and so
sometimes it's that easy. There's another question here. What advice or best practices would you give to maximize the ROI on such a project?
It's a good question. I think, I mean, as I said, it's pretty straightforward and easy to use. At the same time, what's behind, I mean, the graphs and the graph world is not that easy to master, even for, I mean, we've been working with, the team that has been working on imaging is made of pretty young engineers. So pretty aware of all the new technologies and the new things, and I would say eager to learn. And so they were pretty quick to grasp how to work with graph. But a graph is a graph, and if you don't start digging into the details and understanding how it works, it can really backfire pretty quickly, because the performances can be not very good, I would say, or not good at all. And it all depends on the engine you're working with. I mean, it's not the same thing if you're working with something like Neo4j than with another graph technology. So we tried also several graphs, and one of the reasons why we choose Neo4j was that it was the most easy to work with, I would say, in terms of the language. So my advice would be to make sure that you invest enough time to understand the foundations, what a graph is, and how you can work with a graph. And then it's going to be that time that you will invest at the beginning, you will gain it down the road when you are changing or evolving, whatever it is. If it's a custom application for a given enterprise or software that you're publishing, that's the same thing. I mean, what you can learn at the beginning will really help you to properly design the graph and have something easy to implement. For the pure, I would say, considering purely the graphical part and the leveraging Ogma or building this kind of representation that we built, I think the working also closely with Linkurious was a pretty good help for us, because by looking at what Linkurious had developed on their side, I would say the product that they are developing, which is not Ogma, I mean, Linkurious server, I think it was called at the beginning, that helped us also to avoid some of, I would say, avoid some errors that we were going to do if we hadn't had the chance to look at the product. So really, taking inspiration from them was a good start for us.
All right. Let's see. It looks like there's one more question here. It's a two-part question. So the first part, how easy is it for your clients to leverage these graph capabilities? And then did you also get any feedback from them about the added value?
It's fairly easy. I mean, I've been, I was surprised to see that most of our customers or most of our users understand pretty easily Cypher, the language to query Neo4j, and are trying to do some queries by themselves. They are not afraid, and they really like I would say, the simplicity of the language and the ease of extracting meaningful information from a graph. It really depends on the graph, the way you have structured the graph, and that's what we spend quite a good amount of time, I would say, on structuring it the most the way it can be read easily, I would say, and that you can really just go through the relationship and get the type of information you want. But I was pretty surprised that, I mean, I was mostly amazed that they adopted it fairly easily and rapidly, and we didn't get any, I would say, not negative comment, but negative feedback. It would have been easier if you had stick to SQL or these kind of things. So this capability and the graph itself capability, that was pretty important. I mean, for the product, I mean the graphical part, it's always, I mean, the difficulties here is the compromise between the volume of details that you put on the view and what you want to convey, basically. And I would say it really depends on some of our users don't like to build big views with tons of nodes and relationship on it, and some users are really, I would say, at ease when they have tons of nodes and relationships on the view and navigate and are able to smoothly navigate and zoom in, zoom out, and look at the details, click on one node, get the characteristic of the function, for example, and then use a relationship to go to the next one. And I didn't show that, but we also have some kind of path, finding path, so where we also leveraging some of the Ogma functions to find the path between two objects, whatever is in between, for example. So it really depends on the user.
All right. Okay, so it looks like that's it for questions, actually. So we want to thank you all for attending, and also a big thank you to our guest speaker, Olivier, today. This webinar was recorded, so we will be sending out the recording as soon as it's available. But of course, if you have any questions in the meantime, you can reach back out to us. So that's it. Thank you, everyone, and we hope you enjoyed today's webinar.
Thank you.
Thanks.